Okay, today we're starting a brand new chapter. This is chapter 2, and we're going to talk about proportional relationships. That's something that you should have talked a little bit about last year. So let's start with number 1. In this example, Julie is picking teams for her flag football team. She picks 3 girls for every boy. So if she picks one boy, I'm looking at the table now, there are 3 girls. So if she picks 2, you're going to multiply that by 3. She has 6 girls. If she picks 3 boys, you're going to multiply that by 3. 3 times 3 is 9. If she picks 4 boys, we're at 12. Okay, so this is what goes on your x-axis. This is what goes on your y-axis. So we are going to label our y-axis girls and our x-axis boys. So on this side, I'm going to go by ones. Let's go back to that. Sometimes it's hard for me to label the bottom of the graph on this. Same here. So let's plot points. We're not going to connect these. So if I have 1 boy, I have 3 girls. If I have 2 boys, I have 6 girls. If I have 3 boys, I go all the way up here to 9. And if I have 4 boys, I have 12 girls. Okay? So that is our scatter plot showing the relationship between how many boys she picks and how many girls she picks. So let's move on to section C in your notes. Again, they filled in our chart for us. They redid that information so you can still see it. Part C says find the ratio of girls to boys. So this is my y over my x for several ordered pairs on the table. So this is x, this is y. So let's find the ratio. So I have 3 girls over 1 boy, 6 girls over 2 boys, 9 girls over 3 boys, and 12 girls over 4 boys. What you can see about this is these all simplify down to 3. All right, so let's look at part D. Fill in the boxes to show the relationship between girls and boys on Julie's team. So remember we said the girls is Y. This is number of girls here, and that's always Y. And the number of boys is on the x-axis. So if we put this all together, this will give us an equation of y equals 3x. That's an equation for this relationship. Okay, so let's look at E now. So again, it repeats your equation for you, and it shows your graph. So it says use the equation and graph to determine how many girls would be on the team if Julie chose 10 boys to be on the team. So this is how we can use the equation. So here's our equation. Remember, y is the girls and x is the boys. So if we find out how many boys are, we can replace the x with the new number of boys, and 3 times 10 is 30. So there will be 30 girls. So you can use the graph to do the same thing. So let's go down here. Well, the graph isn't complete because it would keep going, right? You would have to keep going. And if you followed 10 boys straight up here, and where it hit would be your number of girls. So we can't tell by the graph the way we have it drawn right now. F says, use the equation in the graph to determine how many boys are on the team if Julie chose 18 girls. So we can't use the graph either because the way we have it plotted, you can't see 18, but we certainly can use the equation. This time we get girls. So we're going to replace the Y with 18. And to find the number of boys, or X, we're going to divide by 3. X is 6 boys. Okay? All right. So let's just review a little bit. There's a lot of text here. On your notes, the most important thing is the highlighted portion. So when you have two quantities that are proportionally related, the ratio of each Y value to its corresponding X value is constant. That means that value, you're always going to have that same ratio. This constant, and this we're going to talk about this more, is called the constant of proportionality or the proportional constant. And in this equation, this is your constant of proportionality. We're going to see this over and over again in the next couple sections. All right, we are going to look at number 2. And I think I talked about this in a couple classes before about making homemade root beer in a big garbage can. So Carmen is making homemade root beer for an upcoming charity fundraiser. The number of pounds of dry ice to the ounces of root beer extract, which is flavoring, is proportionally related. If Carmen uses 12 pounds of dry ice, she will need to use 8 ounces of root beer extract. So the first thing they want us to do in A is write a ratio or proportional constant that relates the number of pounds of dry ice to the number of ounces of root beer extract. So dry ice on the top and extract on the bottom. So it says we'll need 12 pounds of dry ice to 8 ounces of root beer extract. If you reduce that, we get 3/4. If you divide that by 4, this is the reduced ratio or proportional constant. So B says we're going to flip that upside down. This time, write the ratio or proportional constant that relates the number of ounces of root beer extract. So it's going to be extract to the number of pounds of dry ice. So dry ice is on the bottom. So you really have to read carefully. So this time it's flipped upside down. 8 to 12. 8 ounces of root beer extract to 12 pounds of dry ice. And this time, this is 2, sorry. Going back, this is 2. So this will be 2/3. It's flipped upside down. So 3/2 for this one, 2/3 for this one. Okay, it's super important that your proportional constant depends on how you are reading this. Okay, so make sure you read this carefully. All right, so now let's look at part C. Let's make a table. It says complete the table below to show the relationship between number of ounces of root beer. So we're making that X, the extract, and the pounds of dry ice is Y. So if you don't need any root beer extract, then you don't need any dry ice. Okay, so let's go back here and remember what our constant was. If pounds of dry ice is Y, that goes on the top. So we are going to use this one. The dry ice is Y for this one, so we're going to use 3/2. So if we have 1, then we have 3/2 or 1/2. If we use 2, we're going to multiply by 1/2. That's our constant of proportionality. 2 times 1/2 is 3. If we have 3 ounces of extract, we're going to multiply by our constant of proportionality, which is 3/2 or 1/2. So 3 times 1/2 is 4/2. So the opposite applies here. If we have 6, it's something times 1/2. So you can divide 6 by 1/2, and that gives us 4. Here they give us the x. We're going to multiply that 8 times the constant of proportionality. So 8 times 1.5 is 12. All right, let's label. So remember, our x is always here, our y is always here. This is going to be pounds of dry ice on the y-axis. And then this is going to be ounces of extract down here. Okay, I'm going to go up by ones, but I'm going to skip every other line because my writing's big. So this one should be 1, and I'm going to label 2, 3, 4, 5, 6, 7, 8, 9, and the last one's 10. This one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 10, 11, 12, 13, 14. Okay, so let's graph our points. I have my 0, 0. I have 1, 1.5. I'm going to graph in between. 2 is at 3. 4, or no, 3 is at 4.5. Skip 3. 4 is at 6. Whoa. 4 is at 6. And then I have 8 is at 12 all the way up here. And I think this erased some of my points. So 1 is 1.5 right here. Okay? So if I draw this line, look at this. It goes through 0 and the rate stays the same all the way through. Okay? All right, so we have a couple other questions here. What is the proportional constant for this relationship? If we go back, our proportional constant is this, what you're multiplying by every single time. So in this case, it is 3/2. That's your proportional constant. E says, write an equation that shows the relationship between the number of ounces in root beer extract, which is X, and the number of pounds of dry ice, Y, needed to make homemade root beer. So we have the amount of dry ice equals 3/2 X. That's our equation. All right. So the unit rate is another word for the proportional constant. So proportional constant and the words unit rate are interchangeable. Okay? So let's look at, this is number 5 in your notes. In the previous problem, Carmen was making homemade root beer. Express the proportional constant at a unit rate. And remember, we said that the proportional constant and unit rate are same thing. So we're still at that 1.5 or 3/2. Same thing. What would the unit rate be if you interchange the roles of X and Y? We talked about that. We would just flip them over. So it would be 2/3. Okay, that's all we're going to do for today. I will do the second half next week.